Number 31 combines the benzene addition reactions that you learned from the first exam with the benzene addition reactions you learned from the third exam. So our goal is to take a benzene ring and turn it into this, a benzene ring with 1 fluorine and 3 carbons coming off of it. And so the only way we've ever seen to add fluorine to a benzene ring is through that path where first you add an NO2 to the ring, you turn that NO2 into NH2, you turn that NH2 into N2 positive, and then you turn that N2 positive into fluorine. There's no other way of directly doing this. And as far as adding the carbon chain is concerned, well, that's a very straightforward reaction, so let's do that first. The way you add carbons to a benzene ring is, well, let's see, I want to add 1, 2, 3 carbons. So I'm going to do 1, 2, 3. Now, on the carbon that I want connected to the benzene, let's say that's 1, 2, 3, I want carbon 1 to be connected to the benzene. I'm going to put a double bond O and a Cl on that carbon. And then I will also have AlCl3. And what that will do is it will connect those carbons to the benzene, but there will still be a double bond O on it. So I add those 3 carbons, and carbon 1, basically the benzene attacks carbon 1, the chlorine gets kicked out, and so you're left behind with just that double bond O and the carbon chain. And now there's an easy way of getting rid of that double bond O by using zinc mercury with HCl. And that just removes any double bond O's that are a single bond away from a benzene ring, like this one. So now I have that carbon chain added. Now, the first thing to point out is, why did I do this step first and not add this stuff? Well, remember how carbonyls direct on a benzene ring. Carbonyls are moderate withdrawing groups, moderately deactivating groups, and therefore they direct meta. So if this is the position over here, meta is 1, 2, 3. So if I added something with this, I'd have it sticking off of here. But we want the fluorine to be para, directly opposite, a 1,4 bond. So I don't want that. So I'm going to get rid of the carbonyl. Now I just have a carbon chain. Carbon chains are weak donating groups, weak activating groups, and therefore they direct ortho-para. And if you have the ortho positions available and the para position available, you always add para first if you have those 2 options. So now I'm free to start doing this. Now what are the reactions I need here? First of all, how do I get NO2 onto the ring? HNO3 with H2SO4. That will put an NO2 group onto the benzene, and because the methyl or the carbon chain is already on the ring, they're the ones doing the directing, so the NO2 gets added para. Now what I can do is I turn that NO2 into NH2, and there are a couple ways of doing that. You just need a reducing agent. So the ones you'll usually see are either Fe, OH minus, and I think it's HCl. So when you see iron, that's really the only situation you're going to be using it. That's one option. You could use H2 with catalyst. You could use LiAlH4. Any of those will do their job in turning that NO2 into an NH2. Now I need to turn that NH2 into N2 positive, and the way you do that is with HONO, H-O-N-O. Another way of writing it, which would also be correct, is NaNO2 with HCl, because what NaNO2 with HCl does is it makes HONO. So it's basically the same thing. And what that does is it turns your NH2 into N2 positive. So that carbon chain is there forever, it's nice and unchanged, but now we have N2 positive. And N2 positive is great because if you go back to your lecture notes, you'll see that it can become like 7 different things. But the thing we want it to become is fluorine, so the reaction we need to use to go from this to our final product is HbF4, and that'll take us home. So first add your carbon chain using the Friedel-Crafts reaction. You have a carbonyl and you decide, do I want to direct meta or para? I want to direct para based on the structure they gave us as our final our product we want to make. So I get rid of the carbonyl first using zinc, mercury, and HCl. Then I use HNO3 to get the NO2 group on, which can then, through this long process, become N2 positive, which is a great thing for replacing things on the benzene. It can become OH, it can become CN, iodine, chlorine. basically it can become pretty much everything that you need. But in our case it was fluorine, so we use HBF4.